I'm here to talk about AI agents, but first let's do a really quick reality check. AI agents in general, from a really high point of view, is just an HTTP server. HTTP service that is gonna get a request from a user, usually containing a user prompt. That agent will then do another HTTP request to LLM, instance OpenAI, Gemini, Anthropic, or whatever. This LLM will usually reply asking for tool execution. The AI agent will then execute this tool, or several tools. This can be, of course, in a loop. And then we're going to do another request with this tool result saying, hey, look, LLM, this is the tool result now. And with all that information, with all that context, the LLM will reply to us with, oh, this is the final result now. And now maybe with that, we can close the cycle and give our user back response. Usually we're doing that in a chat, could be a mobile app, could be a front-end interface. But the interesting fact here, this is usually going to take several seconds. When we were talking about HTTP requests, usually say, we're saying back in the day that we should do HTTP requests that should last like a couple of hundred milliseconds, maybe even less, microseconds. Millisecond. Phoenix came around, like we're bragging ourselves that we're measuring things using microseconds to reply to user, grabbing stuff quickly from the database and replying to the user. And suddenly we're now taking like 4 or 5 seconds to reply to our users. And because of this new way of dealing with HTTP requests, this is something that is changing our way of dealing with infrastructure, with how we're dealing with runtimes, with our ecosystems of how we're going to deal with that. A lot of people are asking, which is the ecosystem that can run this kind of workflow, which is well suited for that? Usually people say, well, Python is not good for that because there's a global interpreter lock, Ruby, not so again. And people, of course, think about, can anyone take a guess? Yeah, JavaScript. JavaScript is usually what people think about, but they have a good reason, because JavaScript, Node.js on the server, they have a good way of dealing with I/O async requests. So they are usually what the people have been using. Go as well, have a good concurrency story as well. But of course, I'm very biased, and I think this kind of workflow is perfect for Elixir, for our ecosystem, our runtime, our VM, and I hope you agree with me as well. I even posted this a little bit polemic here, that I see that a lot of the AI agentic frameworks, especially in Python, are kind of replicating what we already have in Elixir, in Erlang, in the Bean. And they are talking about orchestrating small agents through messages, communicating through messages. Yeah, well, we have the actor model already for that. They're talking about error recovery, and of course we already have like fault tolerance. We already have supervision trees, and yeah, a lot of that stuff. But yeah, let me introduce myself. My name is George Guimarães. I was one of the co-founders at Platform Attack, where the Elixir language was created. So I'm still friends with José, and I also co-founded Source Level. I was working previously at a Brazilian fintech, dealing with AI agents as well, and now I'm working at New Gem, and yeah, happy to be here. Woo! Little bit of a disclaimer, no code here. No intellectual property here is from previous employments. I've not used anything there that in making of this talk. Code here is abstract. I'm talking about how to use libraries and frameworks. And the views here are solely those of my own. These are my opinions, okay? And I'm talking. I want to talk about like a full stack, how we can build stuff in Elixir, very well integrated, very well cohesive, and I'm talking that like I'm saying a lot about full stack AI solutions. And one of the examples that I want to show you here very quickly is how you can, you and I can build tools, AI agents that have several different parts inside the same runtime, inside the same code base. So internal dashboards, multiple chains working together, RAGs, in-memory RAGs, which is really different from what we usually see using vector databases, MCP clients, and even throwing in neural networks for image classification. So internal dashboards is a really cool thing that we have because we have live view. And cool thing that I like to do is to build internal dashboards for the users of the company, especially as a playground to use your own agent with your own data. So you have access to the messages, you have access to all the tool callings, and even better, you have access to the business data and the business rules. So you don't have to re-implement a lot of stuff. It's a cool way to prototype stuff without having to go to the front end or go to the mobile app as well. So you have a cool way of building a lot of stuff using live view already. And moving over really quickly to the multiple chains, I think usually when people are building chains, are building agents in Elixir, and I really like to use LangChain, the Elixir library for building that. We kinda, the first version of the agents that we build are kinda usually really big, and our system prompt ends up being this really messy, really complicated, lots of instructions there, and trying to do a lot of things together, and kind of adding, aggregating a lot of tools. So I had some experiences where we had like dozens and dozens of tools together, and the LLM were kind of lost on which tools were better suited for the small prompt that the user would input to us. So the way that we got rid of that uncertainty was to actually separate into multiple small chains to actually separate those tools. So we had like, oh, this request is talking about transferring money. So let's get that to an agent with only the tools about that specific functionality. Oh no, this request is about generating images. So let's get all the tools about that and forward that request to that. So really helped us to be more accurate. And later, I think that it would really help anyone to manage costs as well, because it would help you to choose smaller models for those different chains. And the example here that I want to show is how to use multiple personalities, multiple chains to add a personality to your agent. So using LangChain, I have here an example of a tool. This is a tool to call Perplexity, just to search the web for current information about regulations, news, market conditions. Pretty simple. This is the declaration of the tool that the LangChain uses, and this is the actual execution of the tool, which is just calling a module that's going to have the actual HTTP call to Perplexity. So nothing fancy here. And the way that we could use that is to use that in a chain like this, where you could have different tools like a reg tool, a wire confirmation tool, perplexity tool, and then you could have the real declaration here of the chain, where you add those tools, add a system prompt here, which again, the system prompt would be really difficult, really different from just the simple messages, this simple message here. And the result of running this chain, actually, let me run this chain first. So here is an example of asking, what is the current transaction limits in Brazil? We have this infrastructure in Brazil called PIX, P-I-X, and running that, Perplexity helps us to search the web, and OpenAI here, this is an example running OpenAI, replies us with that information. So it's pretty, how can I say, boring. So has bullets there, kind of replies very strict information, but we can do more with that. We can input this message into a new chain, which doesn't have any tools, but has this personality system prompt here, which is responsible to rewrite this response to be more conversational and helpful, to keep all the technical details, but keep it warmer and more personable. This is actually the prompt that I used and to get this response here. And we've added a lot more personality into our response. It's much more conversational. Hey, emojis, of course. Great question about PIX limits. Oh, here's what the central bank says. You can send up 20,000 reais during the day, but at night it drops to 1,000 for security. So it's much more the way that you're gonna send this information to a friend. It's not like the bullet points, more like informational from a system that from the previous example. So really cool example, very small agents for specific information chained together. Another cool thing that everybody's gonna have to do, a reg. Usually your company already has a knowledge base for employees. Usually that is a specific business procedures and issues resolution. So that is not really good because that is usually more for internal procedures that you don't want the agent to spill that information to everybody. So I recommend creating a new knowledge base, a new set of documents where people in marketing, product engineering can write knowledge to your agent. And I found out that the public relations style articles, they don't perform really well. And people always say that actually all over the web. So if you search more about this, how to feed information to regs, they say that bullet point, factual, question and answer style is the best. So exactly like the example that we saw previously before the personality chain. So the example that I bring here is actually how we could take advantage of Elixir being really good at using machine learning and using Bumblebee, NX, all those tools, and you can build a reg system. You can build a system that doesn't need a vector database at all, and you can prototype things really quickly. What I would recommend you do is to create a serving, like for you to do the embeddings or vectorizations of your reg questions and reg contents. So for instance, here I'm using this model here, this GTE small. This is a model coming from Hugging Face, and using Bumblebee. Bumblebee already has a lot of cool stuff to help us get the settings from this model and create us the configuration for the embeddings. And we can use that configuration to create a serving, create a small Elixir process that is going to be responsible to reply us the vectorization of whatever stuff that we are asking for. Later, we can create a Jinx server. That's one of the things that I tried to do, is to create the texts that we have, like all the knowledge base that we have, create chunks of text based on the maximum chunk size that your embedding model can handle. I'm going to show you an example of this function. We get the chunks and create the indexes using the hierarchical, navigable, small world algorithm. And then, really, really simple, we just use persistent term here. So it's going to be persisted in the memory of the Beam virtual machine instead of being saved into a database. So this is really the part that we are changing. Until this part, everything is equal. If we're going to use pgvector or whatever other vector database, you would have to do everything here. But here we are just storing that into a reg database. And then I'm using Jinx server here, but Jinx server is not really important here. I would not even do that anymore. Like, this index function is really costly. You don't want to do that in an init function. And this Jinx server is a temporary one, so it's gonna just spin up, create a persistent term, and then access. So it's just a temporary fire and forget thing for us. And the chunk part is, there's a cool library called Text Chunker with a bunch of strategies for chunking your texts. So there's a cool strategy called recursive chunk that everybody, have great experiences using. So that's the one that I usually use whenever I need to do stuff like this. And to create and to really index that function index, we use that serving that we created before to create all those embeddings. We create the index. We then add all those embeddings one by one to that index, and that is it. We return the complete index from that. And to query that, it's the inverse. So we retrieve the data that is in the persistent term, the index and the chunks. We embed the query the message, the query that we wanna query. So we have the embedding again from that, and we run that embedding into our HNSW-lib and run a simple. In this case here, I'm using the nearest neighbor search, and that label will contain the nearest instances of all those chunks that I have, and then I just return. Using that, I just return the actual chunks that we need. So kind of simple here. This is stuff that I did to not need a vector database at least for the first part. The pros that in this approach is that the latency is almost zero. We have no other moving parts. So we don't have to deal with vector database or graph database. But of course, this is not the usual way that AI researchers are used to think about the stuff and to think about the code. And you probably need a GPU here, unless you're using an embedding that is CPU friendly. And you're gonna need, depending on how much data you have on your chunks, you're gonna waste a little bit of RAM here as well. Yeah, but moving a little bit quick, cool thing that I think is kind of overlooked as well, MCP clients as a way to give autonomy to other teams in the company. I think that we can use that for us, especially in teams, in companies that are like a bigger size with multiple teams. We can use this idea to ship features to the AI agent. So the agent can be an MCP client, and those internal teams can act as MCP servers, almost like a BFF for tools. We like Zoe, which she used to work with me, and she created this cool project called Anubis MCP, which abstracts all the stuff that you need to create MCP clients and MCP servers in Elixir. And I think a good architecture with that, and even using this Elixir distribution, is to have like the MCP server as a way, the MCP client, MCP client as a way of connecting with MCP's server inside the companies, and those MCP servers could be any other language at the company, Python, Ruby, TypeScript, JavaScript, whatever, and whichever tools that those teams exposes through MCP are available to the chain as well. So it's a cool way of not having to understand all the business rules, all the validations that those teams have, and a cool way of having them to be part of the development of the agent as well. And again, this is really a thing that I think Elixir has a great advantage, because when you have a connection like this, a one-to-one connection always opened, especially using SSE, yeah, Elixir is great for that. Of course, pros, like it's an industry standard for now. MCP has a relative good support in every ecosystem. Python, Go, Ruby. I think like some of the cons that only now we're seeing like streamable HTTP on MCP, and MCP still has to define a good way of doing auth authentication on that. And another deficiency is that MCP exposes tools, not workflows or agents. That's where HDK, H2H is gonna maybe solve that as well. Another cool thing that I think is only possible because of Elixir, the way that we have all those processes and supervision trees, is that imagine that customers can upload in your chat images, include maybe not safe for work pictures, underage pictures as well, and you need to detect those pictures. You need to have a way to detect those, maybe alert the user, maybe delete those pictures from your database. And you can use one of the models from Hugging Face. For instance, this one is an open model to detect not safe for work images. You can create a serving, again, using Bumblebee, using NX here. Actually, Bumblebee doesn't have a good standard configuration for this model. So I had to create this image classification function, which is here. So I had to manually configure Bumblebee to understand what that model is about. But it's pretty simple stuff as well. And with that serving running, with that model running in our supervision tree, it's pretty mind-boggling for me, because now imagine you have an app, you have your repo, which connects to the database, you have your endpoint, which serves your HTTP requests, and now you have a neural network as another module, which you can call, and it's a neural network inside your application supervision tree, which is super awesome. And whenever I talk about this to folks using Python, they are like, how did you manage to do that? And I said, yeah, I use Elixir. This is easy for us. This is no big deal. And to use that, yeah, this is simple code that just gets an image, resizes it using VIX, and reshapes it using NX, and uses the NX serving, using that serving name, using the now reshaped image as the input tensor. And then we have a prediction like this. Like, is it not safe for work, or is it safe? And you can do stuff based on those predictions. So yeah, it's just easily available, just any other module. No need to deploy a separate ML serving. So people are using like Ray IO, Vertex, Hugging Face spaces. But of course, you're gonna need more RAM for that. And high availability if you're using Kubernetes pods may be a little bit tricky, because you need to coordinate stuff like, oh, when one pod is gonna be up, when one pod is gonna be down. So chaining everything, we have one big cool thing, which is the supervision tree. We have superpowers here in the Elixir virtual machine. We can do stuff like, oh, let's do Elixir distribution and separate what has access to GPUs, and do stuff like, oh, neural networks here, the RAG systems here, but stuff that doesn't need that, like, oh, the live view dashboards, the MCP protocol, the external APIs. Yeah, let's move that to machines, hosts that doesn't need GPU access at all. So yeah, yeah. Mesh of final thoughts here. I love the observability that we have put in using telemetry, using open telemetry as well. So in LangChain, in Phoenix, in Oban. Testing chains with tools is a little bit tricky still in any other ecosystem, because sometimes we need to call OpenAI, and I really don't like that. I really think that LangChain should be renamed, because the Python's LangChain has a really bad rep. The RAG component that I showed you, I would rewrite that to use an agentic RAG, stuff that I just finished a course about, and I want to write a blog post about it. And I really do think that MCP servers and agent-to-agent frameworks, they now turn requests into a more stateful web, not stateless anymore. And I think Elixir is a great runtime for it. Yeah. I also document some of the libraries and stuff, and talks and resources in this repo here on GitHub. It's a cool way of showing and bookmarks for stuff that I like. And yeah, that's it. Thank you. Thank you very much. Any questions? Do we have time for questions? Yeah. Sure, for the other people.
Cool. Look, thanks so much for that. It was interesting. You were saying at the end they're moving RAG to agentic RAG. You also kind of walked us through a bunch of code showing vector retrieval in some detail. I was just wondering, like, I have a sense that a lot of these systems started off with unstructured knowledge bases and sort of doing vector retrieval, and now with more API-based stuff with sort of agentic and MCP, you're starting to have access to more structured data systems. And my interest is I sort of come from like an SQL kind of space. And I'm just wondering what you see around trends in retrieval. Is it becoming sort of more structured systems working with API calls and database systems? Or do you still absolutely have to build these systems on kind of vector, whether it's like, you know, in memory or kind of an external vector database?
Yeah, that's a great question. I was discussing that. Yeah, I was doing a course on agentic RAG and stuff, and we were discussing exactly that. The thing is that we kind of agreed upon during the course is that the problem nowadays is not that very much about RAG or this AI stuff. It's much more about retrieval and how we're gonna do that. And we're kind of now moving back towards, like, the pendulum. A pendulum always swings up to a side and then goes back to the other side. And I think, or at least we were discussing that, we're seeing more and more people going back to the quote-unquote old days of how to retrieve information. So going back to SQL, going back to Elasticsearch ways of doing retrieval, instead of just doing embedding. And kind of how the game now is how to merge those two approaches and compare those two and maybe have those two work for the benefit of the user. So that's how I use that. And I would love like to have an open source product that where I could use, and I would feed information, maybe PDFs, may connect with Google Drive or Notion or Confluence, and have that help me understand my data and help me answer queries on that. And I'm still yet to see. So yeah, people are moving away from just doing embeddings, and still like, yeah, how we're gonna use the old approach together with embeddings.